Hello, welcome to my presentation. My name is Zhou. I will introduce our recent work, Dialogue State Checking with Multi-Level Fusion of Predicted Dialogue States and Compositions. Dialogue system can be widely used in our daily life, such as table reservation, ticket booking, business consulting, etc. The figure on the right shows the basic structure of the traditional human-machine dialogue system. Dialogue state checking, which is short for DST, is a part of dialogue management component. The function of the DST is to check the constraints and users' requests in a dialogue, which is vital for the next step in the pipeline, namely selection of the dialogue policy. DST gather the information normally from the compositions and sometimes from the previous dialogue states. Here is an example of DST. As the table shows, the constraints in the DST are always represented as the slot value pairs. On the right is our composition. We should first pay attention to the second turn and third turn in the dialogue. In the second turn, the user first adds a constraint to slot, restaurant name with value White House, and then release the constraint in the third turn, since another constraint slot, restaurant book people, conflicts with the ontology. In the paper, we define such problem as the deleted value problem. When we focus on the last turn of the dialogue, the user adds the constraints to the slot, taxi destination through the coreference representation, since the token restaurant refers to the slot value in the restaurant name. In our paper, such problem is defined as the related slot problem. Both problem is relatively difficult for the ST task. From the dialogue above, we can see the information nature of the context and the dialogue states are quite different. The nature of the compositions is complete. However, sometimes it can be indirect. While the nature in the dialogue states is direct. However, when it exists false prediction, it can be incomplete or even erroneous. Thus, the motivation of the paper is to find a method which can combine the advantage of the information nature between the context and the previous dialogue states for the ST task. Then, the problem comes to how to utilize the context and how to utilize the previous dialogue states. Some methods utilize a part of the context, which is normally the last or last two terms in the dialogue. This method always combines the previous dialogue states as the information source for the dialogue history. They are based on the assumption of Markov property in the dialogue. However, the methods will easily carry over the fault prediction due to the dropout mechanism for the history compositions. Some methods encode the whole compositions through the continuation of the context. They employ the attention mechanism in each tokens. However, such methods always counters the maximal sequence length dilemma. Especially for the BERT-based encoder, the available pre-trained model is limited by the sequence length. When we come to the problem, how to utilize the previous dialogue states, some methods apply the latent representation of the previous dialogue turn for the previous dialogue states. The approach is not interpretable. What's more, modeling with explicit slot connection shows promising performance to solve the related slot problem. It seems that extraction information from the context with a hierarchical structure with the explicit introduction of the previous dialogue states may be a good option. Besides, how to merge the information from the two sources is still a problem. Here is our solution. The net is a hierarchical structure. Two BERT encoders are the input layer of the model. The fixed BERT encoders the slot name, previous dialog states, and slot value. The tunable BERT encodes the compositions. We employ two fusion gates to merge the information. The turn-level fusion gate is on the root of the model. It merges the information between the compositions and the corresponding last dialog states in each turn. The passage-level fusion gate is on the top of the model. It merges the representation of the dialog and explicitly introduces the last dialog states on the top. To prove our net is a good solution, we designed 5 networks to answer the following question. Does multi-level fusion work? Does attention mechanism also work in the merge between the compositions and dialog states? Is fusion with context and the corresponding last dialog states in every turn necessary? We remove the passage level gate on the top and the related data flow. It is the turn level approach in the paper. We remove the turn level fusion gate at the bottom and the related data flow. It is the passage level approach in the paper. We also remove both the passage level and the turn level fusion gates as the base approach. To verify the function of the turn level fusion gate, we use the attention mechanism to replace the turn level fusion gate as the no gate approach. We conduct the comparison between the turn level approach and the no gate approach. To prove that, it is necessary to merge the context and the corresponding last dialog state in every turn. We also design the single turn approach, which utilizes only the last dialog states and the compositions. We conduct our experiment on the Multiwords 2 and Multiwords 2.1 datasets. They are multi-domain task-oriented dialog dataset. The latter fix many files, annotations, and users' utterance. Since we introduced the previous dialog states in the net, we train our model with 2 stages. The first is the teacher forcing training. In the stage, the previous dialog states are all from the true label. The second is the uniform schedule sampling, which use half previous dialog states from the true label and half from the actual prediction. The general performance in our evaluation is the joint accuracy on the above 2 datasets. Besides, we designed another 2 experiments to evaluate the performance of our model to the related slot problem and the deleted value problem. In the related slot problem, we first select multi-domain dialog with taxi domain from the dataset. Then we manually replace the explicit expression with core reference. An example is on the left. We then use the successful training rate with slot, which occurs core reference to evaluate the performance. In the deleted value experiment, we select a dialog with deleted value problem, then manually summarize the dialog template. An example is on the left. We also use the successful check-in rate to evaluate the performance. Here is the result. The general performance shows that our approach reached the SOTA performance. Table 2 shows that the importance of the 2 stages training. The method with stars means training with only teacher forcing, since the base approach does not use the previous dialog states. It is only trained in teacher forcing. The rest are trained with 2 stages training. The improvement from the uniform schedule sampling may come from the introduce of the natural data noise. Table 3 shows the fusion gates improved ability of our models. Table 4 shows that it is necessary to merge the context and the corresponding last dialog state in every turn. The improvement may come from more data noise in the training phase. Table 5 shows that in our approach, the fusion gate is more efficient than the attention mechanism at merge information from different sources. Here is a case analysis. The figure shows the weight in the fusion gate. The dark color represents the gate pay more attention to the previous dialog states. When we focus on the first turn in the dialog, the user first adds the constraints to the slot attraction name. Thus, the color in both turn level and passage level fusion gate show a light color. When we focus on the last turn, the user adds 3 constraints in this turn. First is the slot, taxi departure. The hotel is a co-reference. The taxi departure value can be found in the slot name, hotel name. Then is the slot taxi destination. The value is in the user's utterance. Besides, it is also the slot value of attraction name in the previous dialog states. Last is the slot taxi leave at. The value 7030 can be found not only in the last utterance. When we see the fusion gate map, the weight of taxi departure, taxi destination, and taxi leave at is from large to small, which means the fusion gate to some degree learned the ability to balance the information from the 2 sources. To summarize, in this paper, we designed the experiment to prove the fusion gate is efficient at merge information from different sources in our model. The turn level fusion gate is sensitive to signal tokens from the current turn utterance. The passage level fusion gate is relatively stable. Uniform schedule sampling training is crucial for improving our model's performance. The entire history of dialog states helped to extract information in each dialog utterance, since it introduced more data noise in the training phase. That's all my presentation. Thank you for your time.